What is steel? Steel is an alloy of iron and carbon. The major constituent of steel is iron, a silvery white lustrous metal which is malleable and ductile and relatively soft. But carbon changes these properties. Adding very minute amounts of carbon to iron changes it to steel, a hard, tough, strong, durable alloy. Man has been using tools and structural components made of steel for thousands of years. Primitive man even discovered, no doubt by accident, that heating iron tools in fires improved their quality, making them tough and bendable. And if charcoal was present, the metal came out of the fires even harder than before. Heat treating is thousands of years old. However, the science of heat treating is no more than 100 years old. But heat treating metals is both a science and an art. By controlling time and temperature, we can make steel hard and brittle, like this, or soft and bendable, like this. We can give steel practically any properties we want. There is a tremendous difference between carbon steels and what we call alloy steels, stainless steels, and tool steels. These are all completely different kinds of steel. The basic methods of heat treating them may be somewhat similar, but they are all heat treated differently. Right now we are going to study just one kind of steel, plain carbon steel. This is the simplest kind of steel, a mixture of two basic elements, iron and carbon. For producing steel, the carbon is added in very small amounts, in quantities less than 1.5%. The addition of merely 0.1% of carbon changes the properties of steel dramatically. Carbon steel exists in a variety of grades, depending upon the amount of carbon. So many kinds of steel now exist that a number of systems have been devised to identify not only the various grades of carbon steel, but to identify all of the metals and elements that may be alloyed with them. The most widely used system is the AISI numbering system. AISI stands for the American Iron and Steel Institute. The AISI system is made up of 4-digit numbers and occasionally a 5-digit number. These numbers identify both the base metal and occasionally the approximate percentage of its major alloying component. The first 2 digits represent the base metal. In this case, 10 stands for carbon steel. The 10 also indicates a few other elements that are inherent in the steel, such as sulfur, phosphorus, manganese, and silicon, which may also be present in controlled amounts. But as far as we are concerned, the 10 stands for plain carbon steel, which consists of iron and a certain percentage of carbon. The remaining 2 digits of the AISI identification system represent the percentage of carbon in the steel in hundredths of a percent. So if a metal is identified as AISI 1040, we know that it is a carbon steel. The 10 tells us that. And the 40 tells us the nominal carbon content of that steel is 40/100ths of 1%. Now that's a very small amount, but as we shall see, a very small amount of carbon is all we need